Basic theory of magnetism. The word magnet comes from the Greek magnetos lithos, which means Magnesian stone. Magnesia was a region in Greece that is now Manisa, Turkey. The area contains magnetic stones that have been found since old times. Magnets are made of metals such as iron and steel. Magnets have many features that make them unique. Magnets are one of the most powerful tools in the world. Magnets have two poles, namely north and south poles. The poles of the same name are brought close to repel. The poles with different names when brought closer will attract. Magnetic force comes from the interaction of magnetic poles that arise due to the movement of electric charges, electrons. The north and south poles of randomly dispersed magnetic particles have no magnetic properties. In certain types of metals, such as iron and steel, the particles are arranged in an orderly manner so that they have magnetic properties. The following are the elements that make up the magnet. A. Magnetic particles are arranged randomly. B. Magnetic elements are arranged in an orderly manner. Based on the nature of the interaction of materials with magnets, there are three types of objects, namely ferromagnetic, diamagnetic, and paramagnetic. Ferromagnetism is an object that can be strongly attracted by a magnet. Examples are iron, steel, cobalt, and nickel. Paramagnetics are devices that can be used for magnets, magnesium, molybdenum, and lithium. Diamagnetics are objects that cannot be attracted by a magnet, for example silver, gold, copper, and bismuth. How to make a magnet: rubbing, magnetic induction, and electromagnet induction. The iron is rubbed in a fixed direction, so the magnetometer can be adjusted to go in only one direction. The north pole of the magnet rubbed from the iron tip B to A turns the iron magnet into a magnet with the north pole changing the B end and the south pole at the A tip. So, the tip of the iron that is first rubbed will have the same poles as the poles of the magnet that rubbed it. Here's an illustration. Steel and iron can be made magnets by induction or brought close with the magnet for some time. The tip of the iron or steel adjacent to the pole of the bar magnet will have the opposite pole to the inductor's pole magnet. Magnets can be connected to batteries or wires with a power supply that rotates DC-DC, which is electromagnetic. DC current flows because the DC current can equalize the direction of the magnet on the iron or steel. Here's an illustration. The magnetic poles of iron or steel are formed depending on the direction of the winding of the wire carrier. If the direction of the current is counterclockwise, the A end of the iron or steel will be the north pole and the B end will be the south pole. Conversely, if the direction of the current is clockwise, the A end of the iron or steel will be the south pole and the B end will be the north pole. The application of electromagnet theory in everyday life, namely electric bells, switches, and telephone wires. Electric bell. When the electric bell button is pressed, the current circuit is closed and current flows in the coil, causing the iron in it to become an electromagnet that is able to move the bat to hit the bell so it sounds. Here's an example of an electric bell. A. Electric bell circuit schematic. B. Electric bell switch. The switch serves to disconnect and connect electric current in an electric circuit. However, for the form of a switch like the picture below, it works when the switch forms a closed circuit. The coil of wire acts as an electromagnet that pulls the tip of the iron down. After the iron is pulled down, the other end of the iron will deviate to right and push the stem to the left so that the left and right handles touch each other to conduct electric current. When current flows, the load, lamp, or other electronic device turns on. Here's the switch. A. Electromagnetic switch diagram. B. Electromagnetic switch. Cable telephone. When using the phone, we can receive messages listening, as well as sending messages speaking. The working principle of the telephone is to convert electrical energy into sound energy. When there is a conversation, electrical energy flows in the telephone wire, causing an electromagnetic effect whose strength varies. so that it can vibrate the flexible metal diaphragm on the speaker phone. It is the vibrations in the speakers that vibrate the air inside surroundings and provide a hearing effect for our ears. How to remove material magnetism. It can be removed by randomizing the direction of elementary magnets, such as being heated and wrapped around a magnet with alternating current AC. Magnetic field is the area around a magnet that can affect magnets or other objects. The pattern formed by iron sand is a form of magnetic field of force that is used to describe the magnetic field. The greatest magnetic field is located at the ends of the magnetic poles. This matter indicated by the amount of iron sand drawn by the ends of the magnetic poles. The magnetic lines of force are very close together. Here's an illustration. The Ørsted experiment conducted by Hans Christian Ørsted, 1828, showed that an electric current can create a magnetic field. You do this by observing the movement of the compass needle when placed near a cable that is electrified. The direction of the magnetic field and the direction of the current can be shown using the right hand as shown below. The thumb shows the electric current and the other finger shows the magnetic field. Here's an illustration.